Today we're going to be looking at 4.5, which is the laws of logarithms. Just like I was saying, this is probably one of the most important lessons for the unit on logarithms. On your page you have 5 crucial log laws. Now all of these laws of logarithms you examined on your worksheet last class. This is exactly what I was saying last time about how there are certain shortcuts for logs. All of these log laws are directly connected to exponent laws. So the first law is called the product law. Okay, and what that's saying is that if you have a logarithm, and inside the log there's 2 things being multiplied, then you can break this up into 2 separate logs that are added together. The reason why is because, remember, a logarithm just finds the exponent. So just like a to the power of n times a to the power of m is a to the power of n plus m, when you multiply 2 powers, you can add their exponents. So when you add 2 logs, it's the same as multiplying inside of 1 log. And we saw this on the worksheet last class when we did something like log of 2 to the 10 times 2 to the 5. And this is the same as log of 2 to the 10 plus log of 2 to the 5, which is just 10 plus 5. Okay, so because you can add the exponents when you multiply. Now on your sheet, I think you have half of them are laws with log and half of them are laws with ln. You don't have to worry too much about the ln ones. We're not going to be using a natural log that much. I'll do some examples today, but the most important ones are the log laws. So the second law is, let's do this one in green, the quotient law. Okay? If you have 2 numbers that are being divided inside of a logarithm, that's the same as subtracting 2 logs. The reason why is because if you have a to the m divided by a to the n, it's the same as subtracting the 2 exponents. This is very closely connected to the exponent laws. And again, on the worksheet we saw this with things like 512 divided by 64. And you can check that on your worksheet. That's the same as just taking the log of 512 minus the log base 2 of 64. Okay. You can just subtract the 2 logs individually. The power law is one of my favorites. This is a very powerful one. Get it? If you have an exponent inside of a logarithm, then you can take that exponent and put it at the front as a coefficient. You can change an exponent to multiplication. And this is because if you have an exponent that's an exponent on a power, that's the same as multiplying those 2 exponents together. So having an exponent changes to multiplication. Now the third one we saw last class, it's a very powerful change of base rule. And this helps you to put in your logs into your graphing calculator. And the last one is that if you have a power and a log, because a to the power of x and log base a are inverses, a to the x is the inverse of log base a. So that means that when you put the 2 together, they cancel each other out. Just like x squared and root x. So there's another way that we could say this as well. If you have log base a and then a to the x, those things cancel each other out, leaves you with just x. Okay? Similarly, if you have a to the power of log base a of x, those 2 bases basically cancel each other out, leaving you with just the x. So now we'll put these laws into action. Okay. In the first example, we have 4 terms, but there's 2 different bases. So we've got base 3 and base 2. Now I can use my first product law. If it has the same base, then I can put those 2 together. Okay, and because it's positive log base 2 of 3, I can use my product law. If I'm adding 2 different logs, that's the same as taking those 2 terms and multiplying them inside of just one log. Now the second term is being subtracted, and it's base 3. So these ones are both base 3, and because this one is being subtracted, I'm going to use my quotient law. If I have 2 different logs that are being subtracted, I can write that as one single log and take the 2 inside terms and divide them. Okay, and I've got this plus here because this one was positive. So now in simplest form, this would be log base 2 of 60 plus log base 3 of 2. Okay, and I couldn't simplify that further unless I took out my graphing calculator and actually change that to a decimal. So let me just do that for a second so that you can see. If you want to change that to a decimal, we can't actually plug in log base 2, so I would have to do log 60 divided by log 2. And that's using the blue rule. If I want to write in something with a different base, then I can just divide 2 logarithms. Okay, and then plus log 2 over log 3. So this is actually the same as 6.54. But my simplest term answer would be this one right here. Usually I'm going to leave it in lowest terms unless it's a whole number. Okay, so for part B, I'm adding the 2 logarithms, so I'm going to use the product law. And because they're both base 2, then I can write these 2 separate logarithms as one log. What do I put in the brackets? Inside we have root 12 times root 3. And from grade 10, if you multiply 2 square roots, you can multiply those numbers inside of 1 square root. 12 times 3 is 36. So this is log base 2 of 6. Now if you wanted to calculate that on your calculator, you would have to type it in as a fraction using the blue law. Log 6 divided by log 2 is 2.58. So the simplest form is log base 2 of 6, but you can also write 2.58. Now you try part C. So I hope you had a chance to try part C. Again, because we have all addition here, we can use rule number 1, the product rule, which says that if we're adding a whole bunch of different logs, we can multiply all of the things inside of one single logarithm because they're all base 10. And then you can even forget that you have that log word there and just simplify what's in the brackets. So 1,000 divided by 1,000 cancels. And 3 plus 2 plus 1 is an exponent of 6. So that's a correct answer, but it can become more simple. What I saw some people doing was trying to use the product or the power law, which says that if you have a power of 6, you can move it to the front as a coefficient. But we can't do that because the 6 is only on the x. It's not on the 100. If there was brackets around the 100x, then we could make the 6 into a coefficient. But because this power of 6 only belongs with the x, if we wanted to do that, we would actually first have to separate the 100 from the x. And suddenly my eraser's not working. There we go. Okay, so I could show you how you can simplify this even further. So because these two things are being multiplied, we could break them up again into two separate logs using the power law, product law. Okay, so because we have multiplication inside of one log, this changes into addition of two separate logs. Now the power of 6 is only on the x, so now we can take it and make it into a coefficient. Log of 100 is the number 2 because there's 2 zeros. Log base 10 is a 0 counter. And 6 log x. So that would be the simplest form. For part number D, because we're adding logs, the ones that are added can be multiplied inside of a single log, and the one that's being subtracted can be divided. But there's a problem because we have the n out here. So if we want to put those first two log terms together, we have to put the n back inside the logarithm first. So this would be log base a of x to the n, log base a of x to the 4 minus n, and log base a of x to the 2n plus 3. So now we just have 3 log terms with no coefficients. So now they all have the same base, so I can make them into one big logarithm. Okay, and anything that's being added, these two terms, is going to turn out on the top of my fraction. So the xn and the x4 minus n will be multiplied together. And anything that's being subtracted is going to be on the bottom of the fraction. The x2n plus 3. Okay, so just looking at the arguments of the log, what's inside of the logarithm. And now I can simplify that using the exponent laws from grade 10. So I can add the exponents that are being multiplied, of the powers that are being multiplied. N plus 4 minus n is just 4. The positive n and the negative n cancel out. Okay, and then when I'm dividing two powers that have the same base, I can subtract their exponents. This is log base a. I can subtract the two exponents, 4 minus 2n plus 3. And you'll have to write really small on your page. That would be 4 minus 2n minus 3. When I put the minus sign into the brackets, which is log base a of 1 minus 2n. And you can leave that as your final answer. Okay, so this seems all pretty theoretical. What's the point of doing logarithms? That comes up in the next example. So the whole purpose of doing logs is so that we can solve equations that have a variable in the exponent. And you might want to know 2 to the power of what number equals 10. So one of the ways that we can solve for x is just by taking logarithms on both sides. Okay? Anytime that you have a variable and an exponent, you can solve an equation like that just by taking logs on both sides of the equation. Just like square rooting both sides of an equation or adding 2 to both sides doesn't change the equation, taking logs on both sides also doesn't change the equation. It's still equal. Then we can use the power law to take the exponent and make it a coefficient. So the x gets to move out front by the power law. And it's multiplied. So if you want to move the log 2 to the other side, you just do the opposite of multiplication. You divide both sides by log 2. So x equals log 10, which is, what is log 10? 1. Yeah, log base 10 of 10 is 1, and then divided by log 2. 3.32. Let's check that answer. Is 2 to the power of 3.32 equal to 10? 2 to the power of 3.321928 is pretty close to 10. Another way that you can check your answer is by graphing both sides. So if you want to find out when is 2 to the x equal to 10, you graph them both separately and find out where those two graphs cross. And of course I would need, oh, there you can see the line at the top. So to calculate the intersection, they cross at 3.32. So there's 3 ways that you can check your answer. By doing it with logs, plugging in numbers for x, or graphing. So now I would like you to try part B using the 3 different methods and see what happens. So you can take a moment to pause the video and try this problem on your own. The key to solving the problem is to take the logarithm on both sides. This is something that we do any time that you see an x or a variable in the exponent. Then we can use the power law to take the exponent and make it into a coefficient, because there's only one single base 5 inside of that logarithm. Okay. Now what many of you did was divide both sides by log 5. That's wonderful. And you could even change the right-hand side of the equation into a decimal at this point. So on the left-hand side we're left with 3x minus 2. And on the right-hand side we have log 42 over log 5, which is approximately 2. A little bit bigger than 2. And at this point it becomes like a grade 9 problem. We add 2 to both sides to cancel off the 2. And then divide both sides by 3 to get the x by itself. So when I plug that into the calculator, log 42 divided by log 5 plus 2 divided by 3 is 1.44. And I'll check that using a multitude of methods. So whenever you have a lot of terms in the exponent, it's important to put those terms in brackets. 5 to the power of 3 times 1.44 minus 2 is about 42. So that works. The second way that I can check my answer is by graphing. I can graph 5 to the power of, and I've got to make sure to put the exponent in brackets. 5 to the power of 3x minus 2 and 42. I have to make sure that my window goes all the way up to 50 because I have y equals 42. And then I get 2 lines. And when I calculate the intersection, I get an answer of 1.44. So there's 3 ways that you can find your answer. If this is multiple choice, you'd probably only want to do the checking step. If this is a long answer problem, then you could use your graphing calculator to check your final answer. So same thing happens with example number 3. There's a variable in the exponent, which means that you need to take logs on both sides. So you just take logs of everything that's on the left side and log of everything that's on the right side. Now this is a little bit more complicated because on the right side we have 2 terms. So what I see a lot of my students doing is they'll take the n and they'll make it into a coefficient. But this does not work because the n only belongs with the 1.01. Okay, the n is not an exponent of the 132. So before we can take the n down to the front, we have to divide this up into 2 parts because there's 2 separate bases. So the first thing that we can do is use the product law. Because there's multiplication, we can break that up into 2 separate logarithms. That's the same as log 132 plus log 1.01 to the n. I'll just leave the left-hand side the way it is. Okay. Now the n has only one single base. So now I can use law number 3, the power law, and make the power into a coefficient. Okay, at this point you could even plug in log 250 in your calculator, change it to a decimal, log 132, change it to a decimal. All those 3 numbers are all just decimal numbers. All we need to do is get n by itself. So because these 2 terms are being added on the right side, I'm going to do the opposite of adding to move the 132 to the other side of the equation. So log 250 minus log 132 is n times log 1.01. Yes?
Is it okay to make it 1% 1.01 to n was like 2.2 before you move it into the log?
Excellent question. Is it okay to divide both sides by 132 before you take the logarithms? Yes. You're going to get exactly the same answer. Because if you had log of 250 divided by 132, that's the same as log 250 minus log 132 by the green quotient law. So I recommend doing that. But I wanted to just start by taking logs of both sides just to highlight the common error that happens with this type of question. So now we almost have n by itself. Since n is being multiplied by the log, I'm going to do the opposite of multiplication and divide both sides by log of 1.01 to cancel off the logs from the right-hand side. And now I can plug that into my calculator. So log 250 minus log 132 equals, and then divided by log 1.01. So it's important that you have brackets around the numerator if you want to do this all in one step. So n is 64. And this is the sort of question that you'll see on your final exam That's a long answer problem. This comes off of old provincial exam questions. So to check that the answer is right, we can actually graph 250 and 132 times 1.01 to the power of n. But it's important that the window is big enough. So the answer is 64. So I need to go at least up to 64. And my y-coordinate is 250. So I need to be at least 250. I'm going to go all the way up to 500. And there's my two lines. So finding the window can be really hard for a graph like this. So calculate the intersection. And I get 64.18. Same answer. Okay, another way to check your answer is just by plugging in the number into the equation. So I go back and I actually do 132 times 1.01 to the power of 64.2, and I should get close to 250. Yay! So there's many ways to check. Okay, flip your papers over to the other side and we'll do page 2. Okay, example 4 is a common multiple choice question. So this is working backwards. We have one very complicated log. We want to break this up into many different logs that are all just based on log m and log n. So you can see inside of this log we've got 1000 times m squared times n. So because everything's being multiplied, I'm going to use the product law to break this up into different parts. So I can separate the 1000 from the m squared and from the n. When you have multiplication inside of a single log, that's the same as adding a bunch of different logs. And now I can use law number 3 to make my exponent into a coefficient. And because when there is no base written, it's base 10. So log base 10 of 1000 means 10 to the power of what number equals 1000? 3. So the 2 comes forward. And so now everything is written just with numbers and log m and log n. So that would be the final answer. So now you take a moment to try to change part B into one line that only has log m, log n, and some numbers. So back to question number 4, part B. Any things that are being multiplied will be added together. Any things that are being divided will be subtracted. So any terms that are on the bottom of the fraction are going to be subtracted. So why isn't it plus log m squared? Because root 10 and m squared are being multiplied together. So it should be plus. Okay, I'll make it plus. You need brackets around it because they're both in the denominator. So knowing which terms are going to be positive and negative becomes really important. Anything that's in the numerator is going to be a positive term. Anything that's in the denominator will always be a negative term. Because when you expand that negative sign, it'll make the last term negative. Now we can use the power law to make the exponents into coefficients. So this is 4 log n and 2 log m. And what is log of root 10? Let's see. Log root 10 is 1/2. Because 10 to the power of 1/2 is the square root of 10. So now I've written everything in terms of log n's, log m's, and numbers. That would be a multiple choice question on your test. So in example 5, we're given some equations, and we can find out the relationship between log x and log y just by taking log on both sides. So take log of everything on the left, it equals log of everything on the right. Okay, and basically what this question is asking you to do is solve for log y. Okay, so this is the same as log of 100 plus log of y by the power or product law. And then on the right hand side, anything that is in the numerator is going to be positive term. Anything that's in the denominator is going to be a negative term. Subtract it. You subtract everything that's being divided. You add everything that's being multiplied. Okay, and now we can use the power law. The 3 can become a coefficient. Log of 100 is 2 because there's 2 zeros. 10 to the power of 2 is 100. Log of 1 is 0 because 10 to the power of 1, 10 to the power of 0 is 1. Log of 10 is 1. And then I have 3 log x. So now if I move the 2 to the other side by subtracting, I get log y equals negative 1 minus 3 log x minus 2. Or negative 3 minus 3 log x. So you can simplify it by putting those like terms together. Okay, and similarly, you can find a relationship in question number B by taking log on both sides. And because the 2 terms on the right side are being multiplied, we can use the product law to add the 2 separate parts inside 2 separate logs. Log of 0.001 is negative 3 because we move the exponent back 1, 2, 3 spaces. And root x is the same as x to the power of a half. So using the power law, I can put that half at the front of the logarithm and make it half log x. So log y is negative 3 plus half log x. And that would be the final answer. Log e. And that's all in base 10. Now in example 6, what you would need to do is try to get b by itself on one side of the equation. There's many ways to do this, so I just want you to pause the video for a moment and see how far you can get on your own, and then we'll go over it together. Okay, so hopefully you had a chance to try the problem as much as you could. Maybe you got stuck isolating log b. We'll try this together. All we need to do is get b on one side of the equation by itself. Now the 3 and the b are stuck together inside of the logarithm. So why don't we use the product law to at least separate the 3 from the b. There's not just one way to do this. There's many ways. So I'm going to split those up. And now I can try to get the b by itself. So I'm going to move the log 3 to the other side by subtracting. And I'll move the log c to the other side by adding. So I get log b equals a minus log 3 plus log c. Now I saw that on most people's paper and then they got stuck. If you have log on one side of an equation, you can move it to the other side of the equation, just like we did last week, by making it the base of an exponent. So all you have to do is take the base, the 10, and everything else becomes an exponent. The log 3 and the log c. And there's b. Okay, so to move a logarithm from one side of an equation to the other, it becomes the base of an exponent on the other side, and it moves everything on the other side of the equation into an exponent. We can actually do a lot better than this. You can simplify using exponent laws. So I can show you a little bit of some of the steps that you could do to simplify this. When you subtract two exponents, that's the same as dividing. So that would be like 10 to the power of a divided by 10 to the power of log 3 and times 10 to the power of log c, because the log c is being added. And 10 to the power of log cancels out. 10 to the power of log c is just c. 10 to the power of log 3 is just 3. So b is actually 10 to the power of a times c over 3. There's another way to get that in an easier way, and I think I saw that on Sujin's paper. If you put the logarithms together first. So you can use the quotient law to put these together first. And then move the logarithm to the other side. And that's a faster way to get to the same answer. Now, logarithms work in base 10, but they also work in other bases. So you can also use base e. The rules still apply. So if you have two things being divided inside of one log, or ln, then that's the same as ln a minus ln b squared. I just use the word ln instead of log. Same rules apply. So the power rule still holds. You can still take an exponent and make it a coefficient. Ln a minus 2 ln b. And that's where we can apply the givens. We're given that ln a equals 2. So instead of ln a, we can write 2. And we're given that ln b equals 3. So instead of ln b, we can write 3. So you get 2 minus 2 times 3. 2 minus 6 is negative 4. So you might have seen a question like that in the first section. Example 4, I might have told you that log m equals 2 and that log n equals 3. That's a very common problem. And they'll just give you a number for log m and they'll give you a number for log n. And all you have to do is break it down and then put in the number 2 for log m, put in the number 3 for log n, and you'll get a number as an answer. So this doesn't just hold for natural logarithm problems, it can be for a log problem as well. So in this case we've got log of ab squared. So we can use the product law. This is the same as ln a plus ln b. Now the squared here cannot come down as a coefficient because it's outside of the whole logarithm. Okay, so all we have to do is keep that squared on the outside of everything. That means everything is squared. So we have ln A, which is 2, ln B, which is 3, and we just take those, add them together. 2 plus 3 is 5. 5 squared is 25. And the very last problem is a very typical question that you would see on an exam or a long answer section. So this is also a question that might come up on your final exam. And again, because there's an x in the exponent, this is when you would do log on both sides. So you do log of everything on the left equals log of everything on the right. And because we only have one single base on each side, we can make the exponents into coefficients. So we get 3x times log 2. Log 2 is just a number. And we get x minus 1 times log 5. So you could change the log 2 and the log 5 to decimals, but we'll do it another way as well. It's not an exact answer. So log 5 is just a number. To get x on one side, we're going to expand the log 5 into the brackets so that you get x log 5 minus 1 log 5. And that's 3x log 2. So to solve for x, all you have to do is get all the x's on one side by itself. So I think I'll put all the x's on the right side. So I'll add log 5 to both sides to move the log 5 to the left. And I'll subtract 3x log 2 from both sides to move the 3x log 2 to the right side. And I'm only choosing those sides just so that I have the most number of terms positive as I possibly can have. So all the x's are on one side by themselves. So this is the part that a lot of people usually forget. We have two terms on the right side. Both of them have an x. So we can actually take out the x as a common factor. And then in brackets, we write what's left over. Log 5 minus 3 log 2. And that equals log 5. So then you can divide both sides by everything that's in the brackets. And that would be how you would leave your final answer. So the answer is log 5 over log 5 minus 3 log 2. If we change that to a decimal, log 5 over, in brackets, log 5 minus 3 log 2 is negative 3.42.